above the 1, and you just take out the pi.
What? Is that good?
How did you like
Look at it. Look at it.
Tim, have we get Tim?
I got it.
Yes. He just fixed it.
Okay.
You
So,
missed it.
Get it.
right, think of your original cosine graph usually starts at the top of a bump, and I only want to graph 1 period's worth, so here's my
Where
graph.
are you?
Okay?
Yay.
Questions about that?
I don't know. Sophie, I don't know what...
That's 0.5.
I don't know what's happening.
The bigger, better thing.
Okay. Let's look at example 5. For example 5, I need everyone looking in their books at page 424.
424.
They can hear me.
Page 4.
Making sure.
Yep. Okay? Everybody looking at page 424. Yes. Example 5. We're fine.
36.
Example 5. Okay, what is the amplitude of that function?
Wait, what function? Oh.
Wait, they only give us the graph now?
Or 5.
Oh,
Five.
What's the amplitude? 5.
How do you know that? Oh!
Because that's how high and low it goes.
What's the period?
2 pi.
No.
4 pi?
How is it 4
Don't
pi?
tell me I haven't even looked at the picture.
Is it always the second?
How do you know that?
second?
Ooh, it's 4 pi.
The whole period is to do 1 complete rotation before the graph starts over. That's what period means. Okay.
Well, look at that.
Okay?
Because
To do a whole rotation, right? Okay, so if I wanted to write the equation, y equals, is it positive 5 or negative 5? We start going up, so positive. Sine of, shoot, I need to figure out what omega is.
And we know it's a sign because it starts at 0, 0, right?
I need to figure out what omega is.
Can we...
4 pi. 4 pi. 4
Okay,
pi.
it's not this, right?
Ooh,
Let's
But we
write,
know...
let's write the equation. This is 2 pi divided by omega, right? That's how we would figure out the period, typically.
Yeah.
Am I right?
Yeah. Divide by
Okay, so let's multiply by omega. Now divide by 4 pi.
Wow. It's a half.
2 pi, thank you, over 4 pi. Or a half. Oh.
See?
Straight.
Wait, why did you say... Oh.
So the omega that we plug in to make a period of 4 pi is a half. 2 pi divided by a half, flip and multiply, 4 pi. Okay, so you can write 1/2 x or x over 2. Okay, just a question. If you look at example 6, when you're done with 5, would you want to call that a sine graph or a cosine graph?
What is that?
Example 6.
Cosine. Or both. You can do both.
Eeny, meeny, miny,
I'd
moe.
rather call it a cosine
Cosine.
graph
Yeah.
because it's starting not at 0, 0, but up at 3, 0.
But how do you know for sure?
Well, because the sine and cosine are just a shift of each other, right? So I could pick.
Why no,
whichever
but couldn't
one.
it be going up and down though? Couldn't they have lifted it from 0, 0?
They could have shifted it, but what I'm saying is there would be 2 different ways to write it. One with a shifted sign, or I could just start with cosine, which in this case would be.
If it was a shifted sign, then it'd be
So how do we
upside
write that
down.
Right? So for number 6, I would,
No, it would be
instead of
normal.
starting with a sine, I would start with a cosine.
Oh, I
Okay?
It
I
would
just
have
wanted to
to
point
be-
that
Upside
out.
down.
No.
Look,
Oh,
okay.
you're right. Yeah, you're right.
Okay, we need to do the hardest part,
Oh, no.
which is shifting. Okay? So, guys, this is the hardest part. Let's focus.
I do have a
Okay,
legitimate
it's
question though.
what?
They have it written in the book differently. X over
X
half.
over 2.
Does it matter?
No, same thing. Okay, so we are going to talk about phase shifts, right? Just before I said sine and cosine are the same picture, just shifted. So if we wanted to label one as the other, we would need to shift it, left or right. Okay?
Sorry.
Where do we find the shift when I'm looking at the equation?
What example is this?
When I'm looking at an equation, right, we knew where to find the amplitude. We knew where to find the
So shift is going to be, instead of multiplying, it's going to be adding or subtracting.
adding or
right?
subtracting here, right? So we're going to call this thing
Omega.
Now that was omega.
Oh, bummer.
This is a, I figured it was phi
You're
or
a
phi.
farmer.
Wait,
Baseline.
so is this a new concept?
Yep.
I think it's
Wait, what is? Why did you cross out the 0?
Because it's a Greek letter. I can't remember the
It's not a 0,
This
it's
is
a
feet.
This is
It's a
feet.
what?
A feet?
Yeah, it's a feet.
So
Sounds
that's
like
a
a
letter,
feet.
it's not
That's your new
Right.
That's your
It's
new
not
name now.
a 0, it's a feet.
a feet.
Only feet.
Call me P.
Hey, it's like in bird.
Okay.
Notice.
So we would see the feet, but remember, okay? I can never remember which letter it is. There's another one that looks kind of like it. Okay, so remember though, there's this omega is playing into this phi.
Wait, I
okay?
thought omega was like this, like a little 0 thing.
Yeah, that's what I thought.
What?
Omega is a 0.
This is a baby omega.
What's
Look at the baby.
Oh. Then how come it looks
What's the difference between a capital letter and a small letter in English?
Okay.
One's big and one's small, not totally opposite.
No, like an A doesn't look like a baby A.
Yeah, exactly. They still look like
Let's move on.
they have
Okay.
similar.
Phi is not exactly the phase shift. It's not exactly the scoot of the graph. Why? Because of omega. So we're going to call the phase shift,
Don't judge.
okay,
No,
write
I
this
was
down.
laughing at the
The
scoot.
phase shift is phi divided by omega. Okay? Think about this. If typically you're happening in 2 pi, right? Then when you shift over a certain amount, that certain amount that we shift over gets changed if I squish my graph. Right? So you can think about this another way. If you rewrote what's inside, that's a theta, not a phi.
Stop hyperbola.
You could think about it like this,
That's a B, not a B.
Wait, but then the W's cross out.
right?
Well,
This
then you're
would be
back to
another way to
square.
write it. That's how we can see
no,
the
you're not.
phase shift, the thing that actually gets scooted when I mess with omega.
What's a phase?
Okay, you can't just count this. Phase shift is how much you scoot left or right. So normally we would scoot left or right however much we're adding or subtracting, but if I mess with the period, you have to divide by that just like we divide the whole graph by that amount.
Okay, so phase shift
Oh.
is how much you scoot left or right?
Right, phase shift is the scoot left or right. Okay, so let's say we're looking at an example. Please, example, everybody. 3 sine of 2x minus pi. Okay? Typically this would be scoot the graph over pi, right? But the graph is happening twice as fast.
Ooh, ooh.
So we could rewrite it if we want to see
Pi
the
over
phase
2.
shift, exactly, Sophia, as this.
That's not what I want.
Right? Isn't this a different way of writing the same thing?
No.
I don't know.
I have no
Yeah.
idea. Yes.
Right? Because 2 times
Yes.
pi halves is pi.
Mhm.
Okay, but this is the phase shift, this pi halves. Right? Typically we would scoot over pi, but everything's happening twice as fast, so we scoot over pi
But
halves.
then the 2's still in there.
Yeah, because the whole graph is going twice as fast. So this is omega, this is the phase shift.
But then,
Okay?
if you try to do that, then won't it all be messed up?
Nope. Because you're only going to scoot over pi halves in your new world. Right? If you scooted over pi and then squished it, it would be the same as squishing and then only moving over pi halves. Okay? I think you're going to be okay. Okay? So, let's think about what this graph would look like.